Hello my friends! From day one, YugabyteDB was purpose-built to scale and perform across distant geographies. This foundational capability of the database enables us to build global applications, the applications that span multiple geographic locations for high availability, resiliency, compliance and performance. Today, we are going to use the product labs of YugabyteDB managed to explore how global applications achieve high performance and low latency by serving user requests across countries and continents. And we'll do this by following the journey of a company that began as a small local startup and eventually transformed into an international e-commerce giant. Throughout this journey, the company has transitioned through several database deployment options, each evolving gradually in line with business growth and demand. In its early days, the company was solely focused on the United States market, with the primary user base on the West Coast. Consequently, they chose to deploy YugabyteDB in the West Coast-based cloud region across several availability zones. This configuration enabled the company to tolerate zone-level outages, scale easily on demand, and crucially, serve the requests of the West Coast customers with the lowest latency possible. Now, picture yourself as one of the company's first customers, residing in Los Angeles. The product labs allows you to pin the customer phone to the actual physical location, letting you measure the total round-trip latency from the application layer down to the database. So you, the customer, pull out your phone and navigate to the company's website and start browsing through the product catalog. It turns out that the company specializes in selling books online. Does this remind you of another company that began selling books online from a garage and then grew into one of the world's largest corporations? It certainly might seem familiar, right? Eventually, you find the book you want to read next, add it to your shopping cart, and place your order. You are impressed by the seamless user experience. The reason behind this flawless experience is the total latency time for read and write requests, which remains within a single-digit milliseconds range. As time passed, our startup evolved into one of the top e-commerce companies in the United States. The company expanded its operations to sell books internationally. However, despite this expansion, its international business was far from thriving. Let's explore why. Consider a customer in Mumbai, India. She is browsing the product catalog on her phone, finds an interesting book and decides to buy it. Despite finding a book she likes, she doesn't plan to return to this bookstore. The reason? The mobile app was frustratingly unresponsive. The root cause is the total latency between her location and the database storing the product catalogs and orders. This latency exceeds 200 milliseconds for read and write requests. The data has to travel a great distance, over land, under the ocean and across the United States, before reaching the database. To address this issue, the company transitions its global e-commerce application to a multi-region database deployment. They set up primary database nodes across the US West, Central, and East regions. This approach ensures resilience against region-level outages and allows for low-latency read requests from customers throughout the US. Additionally, the company deploys replica nodes in Asia and Europe, ensuring the customers worldwide can browse the product catalog with the lowest latency possible. Let's examine how this new architecture influences or enhances the user experience. First, consider yourself the loyal customer in Los Angeles. You go back to your favorite e-commerce application, find your next book, and place an order. To your experience, nothing has changed. The app is as responsive as it was on day one. Now, let's look at the latency. The total latency for read requests remained within a single-digit millisecond range for you. However, the total write latency is slightly higher, because the database now needs to replicate changes synchronously across 3 regions. And why 50 milliseconds specifically? The US West region is set as the preferred one, meaning it handles write and read requests by default. So, your phone sends the order request to the West location, and the round-trip latency between you and the database node is around 5 milliseconds. Then, the node from the West region uses the Raft consensus protocol to replicate the order to the nodes in the Central and East region. A node in the Central region will acknowledge this change sooner because the round-trip latency between the West and Central regions is about 45 milliseconds. Adding 45 and 5 milliseconds brings the total write latency to around 50 milliseconds, which is barely noticeable by users in the United States. Now, let's see how the new database deployment has improved the experience for our user in Mumbai. Despite her initial hesitation, she returned to the bookstore, selected an appealing book, and placed her order. To her surprise, the app was very responsive this time. The only minor delay occurred while she was waiting for the order confirmation. Analyzing the latencies offers insight into this improved experience. The user's phone connected to the replica node in India, which handled the read request within a single-digit millisecond range. However, the write latency remains high, because the replica node in India had to forward the order request to the primary nodes in the United States. Despite this higher latency for write operations, it doesn't hinder the company's international expansion. Why? Because before making a purchase, most user interactions involve reading data from the replica nodes, such as browsing product catalogs, reviews, and recommendations. Finally, after several years, the company evolves into an e-commerce giant, selling products virtually everywhere around the world. At this point, it decides to transition its mission-critical global application to a geo-partitioned database deployment. With this global geo-partitioned database, the company can handle both read and write workloads with low latencies, no matter where the user is located. Additionally, this new setup enables the company to comply with strict data regulatory requirements in Europe, India, and other countries. The global low latency and compliance are achieved by having the database that can pin user data to the locations where the users reside. Let's examine how the geo-partition deployment enhances user experience. Starting with you, the loyal customer from Los Angeles, you open your phone, pick a book, and place the order. Just like on the company's first day, the total latency is around 5 milliseconds for your read requests and under 15 milliseconds for writes. Now, let's revisit our user in Mumbai. Her phone accesses the product catalog from nodes in India. Additionally, all her orders are processed by the same local nodes. This results in total latency for write and read requests being as low as it is for users in the United States. Finally, let's consider a user in London. This user goes to the app, selects a book, and makes a purchase. The total latency for reads is 5 milliseconds and 15 milliseconds for writes. Hence, his experience is as smooth and flawless as it is for customers in the United States and India. It's time to wrap up, my friends. Through the journey of our e-commerce company, we have seen how it adapted various design patterns for global applications, in line with its growth and business needs. The company began with a single region database deployment, ensuring low latency for reads and writes for its initial users on the United States West Coast. As it expanded, it transitioned to a multi-region cluster with read replicas, enhancing read latency for users in distant locations. Although this configuration resulted in higher latency for writes, which had to be replicated across various US regions, it enabled the company to withstand region-level outages. In its final phase, the company adopted a geo-partition cluster. This move not only aided in complying with international data regulatory requirements, but also achieved low latency for both read and write workloads globally. So there are many database deployment options available for your global applications. The product labs showcased just 3 of them. If you are interested in exploring other ways to deploy your application in YugabyteDB globally, I encourage you to check out our technical documentation for additional global design patterns. Enjoy building global apps on YugabyteDB, distributed Postgres that scales and never fails.